channel. Now to begin with, let's link what we did yesterday. Yesterday we had stopped with a question. So Sandeep sir, I'm connecting myself with the laptop now. Can we do that? Yesterday we posed one question to you. What would happen if Earth had 2 moons? That was the question given to you. Did you find any answer? Did you browse the internet? What would happen? We will talk in terms of gravitation. If there be 2 moons on the Earth, what would happen? We said hypothetically that if there be 2 moons, then it will give more brightness on the Earth even during the night, which means we would of course may save the traffic light during the night. But, big but, if there be 2 moons, then of course it will bring some disastrous effect. We'll be discussing on that one. Can you guess why? दुईटा मूनले के गर्छ होला? The first thing is that दुईवटा मून हुँदाखेरि force of gravitation on the earth would be higher, जसको कारणले गर्दाखेरि जुन टाइड्सहरु हुने कुरा छ, टाइड्सहरुको इन्क्रिमेन्ट एकदमै 6 टाइम्स जस्तो बढ्छ, which means सुनामीहरु, फ्लडहरु कति आउँथ्यो होला, के हुन्थ्यो होला? So that question, I wish that you Google it or you find it in the YouTube र यसको आन्सर खोजेर अझ धेरै जानकारी लिन सक्नुहुनेछ। म यति मात्रै भन्छु र यो क्वेशनलाई यति नै छोड्छु। Now coming back to our lesson today. Last time we talked about the earth as well, gravitation. Earth gravitation. म यसकै कुराहरुलाई जोड्छु। So what we said is that the earth has atmosphere around it. And the atmosphere does not skip from the earth because of the gravity of the earth. Earth pulls the air towards it. That's why the air does not skip from the earth. Now since the air surrounds the earth, that layer of air is called as the atmosphere. Today we'll be talking about the atmospheric pressure as well. We'll be talking about some liquid pressures, and I've got few tools here. Water bottle, of course. I've got water bottles only, in fact. Sabai pani ko bottle nahi cha kya? Yeah, of course, water bottle. Yeah, I got 2 things. One is the nail, and next is the nail cutter. Whatever I got just closer to me, I brought it with me. And because of the lockdown, we can't prepare all of the things required here, sophisticated, like very much sophisticated form. Whatever I got, I brought it here. Anyways, let's begin. So I'm talking about the atmospheric pressure. So the air around the earth, the layer of air around the earth is called as the atmosphere. We'll be talking about the atmospheric pressure as well. So how did we come to know about the pressure? There is a story about the pressure. In almost every book in the pressure chapter, we have a personality that is given in the book. Guess? That's of course Blaise Pascal. Blaise Pascal. This is the person from this person's name, Pascal is given as the unit for the pressure. So why the credit of the pressure discussions is given to Blaise Pascal then? Let's talk on it. Let's talk on it. So I have given one picture there. Look at that figure. What Pascal experimented is that there was a barrel kept at the bottom, and what he did is that about 10 meters long tube is made, and from the top he poured water on it. Do you know what happened? Any guesses? When water is poured from the top of that pipe 10 meters long and the barrel at the bottom, the result was the barrel exploded. What's the reason? Now this led to the conclusion that there is some pressure in the liquid. So we are talking about the liquid pressure and all of those things. We'll be talking about the air atmosphere pressure and every those things today. So our little discussion will be on these 5 things today. We will have a short discussion on the atmospheric pressure. We'll have a short description on the liquid pressure, and of course, if time allows, we'll talk about the Blaise Pascal. And I have been repeating again and again, here we won't be talking about the contents. Please remember that. We are not talking about the definitions or the formulas or the units and all those things. We'll be talking about the conceptual framework. For that, I've got these few tools and equipments, and with these things we will try to prove some of those things. Let's begin. The first one, I've got a glass here. It could be visually right. I've got a glass, so I'm filling this with water. Then almost every science teachers have done this experiment. I've got a paper, so I'm simply covering this with a paper now. Now what would happen if I invert it? Sandeep sir, can you guess what would happen? I'm inverting it now. Now I'm lifting the glass. Do you think the water will fall down? Oh, let's check it. So let's hold it then. So this is the paper, glass and water. So again we cover it, then again trying to lift it. So okay, it's done. Just to prove more, it has water. What does it prove? What does this experiment prove? This is one question. Why didn't water fall out of the glass? This is one question that we will be discussing and trying to find the answer of that. Okay, a paper here. I've got one thing, another thing, paper here. So I'm going to blow this paper. So, okay, is it visible? Right. When I blow it, what do you think would it happen? Does it come down, up? So I'm trying to blow it now. What would happen? Okay, let's try. It's pulled upward, isn't it? I'm blowing this way, but this down paper, it's pulled up. Why do you think so? This is the second one that we would be talking. Why did it happen? We'll be talking on that one. Next one, I've got a bottle as well. So same paper. I'm going to tear it now. I hope everyone knows this one. Let's try it. I'm keeping this paper here. Now I'm trying to blow it. Guess what would happen? Can I blow this paper inside? Or what would happen? So even everyone can try this one. So let me try it. So this is a piece of paper. I just tore it from here and kept at the mouth of this bottle. This is the empty bottle now. Kept it here. I'm trying to blow it inside. Does it go inside when I blow, or what would happen? Let's check then. Oh, it didn't go inside, it came out. What could be the reason? Let me try 1 second. A paper, simply a paper bottle, keeping here. It came out. What could be the reason? Why did it happen? This is the other discussion that we would be doing. Okay. Few more things. Okay, this is a bottle. I've got a bottle. Let me fill up this one. Okay, no. I'm throwing the water now. I'll fill up the water later. That's a very simple experiment. Now, this is the lid cover. So I'm just screwing it now. Now, with these two ends, do you think that I can like toss these two sides? Am I strong enough to do that, Sandeep sir? What do you think?
Why strong enough?
Okay, let me try. No, I can't. Let me try again. Eh? Oh, but I'm going to squeeze this now. It's completely closed. No. Oh, I can. But at least I could squeeze some, isn't it? What about this when I remove the bottle, when I remove this cover? Let me try. What do you think? Can I? Very easily. Okay. So what's the reason behind this? Suppose if this be filled with water, can I do that then? Can I squeeze it? What do you think? So let me fill up with water now. So the things that we are talking here now is all about the pressure. Some are related with the atmospheric pressure, some are related with the air, some are related with the liquid pressure as well. So for the liquid we are using only water here because that is available here, easy also, very comfortable to use. So that's why. Now I'm covering it again. What do you think? Now can I squeeze it? Not at all. Liquid can't be compressed. Remember that. Air could be compressed. If I could have applied much more force pressure on this one, then I could have compressed the air when it was filled with air. But now it is filled with water. So if I try to press it now, I can't at all. I can't. So liquid can't be compressed. This is the another thing that we know. Liquid can't be compressed. No, I can't. So liquid can't be compressed. This is what we come to know from this one. Let me try again. Oh no, I can't. So no one, in fact, because liquid can't be compressed, and because the liquid can't be compressed, liquids are used in the hydraulic machines. Could be the hydraulic press or hydraulic, all those hydro equipments, they contain the liquids, and that liquid can't be pressed. That is the reason. Okay, now with the same experiment, let's do some more. Oh, I've got the nail as well. Let me speak about the nail as well. We spoke about the air, water, and even with the nail. If you could see a nail, one of the end is pointed, and next end is blunt like this. Why? Or if I've got the nail cutter as well. To trim my nail, I would of course need to use the sharp point. Yeah. Oh, is my nail long? No, I guess, but I'm trying. Okay, I could trim it from here. But what about the other side? Can I trim from here? Any other side? No. What is it? Why? The cutting edges of these, like some of the tools like this nail cutter, even could be the knife or the axe, these are pointed. Or this nail is pointed. Why? What could be the reason? Why can't we hammer a nail from this blunt side? Suppose if this could be the wall, why can't we hammer it from this blunt side instead of this pointed side to the wall? A few questions that we'll be talking. So all of these matters that we discuss now, that is related with the pressure. Maybe with liquid pressure or air pressure or even with the solid pressure. Okay, going back to this again, I filled up with water. Okay, I'm trying to destroy it now. Let's do something else. Or even the nail cutter, why the cutting edge is sharp, or could be the knife, or could be the axe, or anything. Those solid objects which are used for the cutting, and their cutting edge is always sharp. Why? Very simple. I'm giving you one formula on the board here, which proves everything, which shows everything. So writing with big letters, pressure is equal to force by area, which means pressure directly pressure is inversely proportional to the area, and also pressure directly proportional to the force. Okay, I've written that one here. So based on that discussion, on that formula, we could talk lots of things. Let's go with the nail now. This pointed edge at this one, it has very less area. The area of this one is very less. Now if you go with that formula, pressure, solid pressure is inversely proportional to the area, which means if it has less area, the pressure would be high, of course. So that means all of those cutting edges, they have very sharp edge, which means that the area would be less, which means the exerted pressure would be high. That is the reason. So if you go now, we can produce lots of questions by ourselves. For example, like sewing needle has sharp edge, why? Or the razors have sharp edge, why? Whatever, all those cutting tools, they have sharp edge. The reason is that sharpness means it has less area. When the area is less, according to this formula, solid pressure is inversely proportional to the area of the object. So if the area is less, in that case the exerted pressure would be high. And because of this, now we can create another many questions. For example, like the house, the base of the house, the foundation of the house is made wide. The reason is that if it has more area, then the pressure exerted on the ground would be less, which means that the house may not like imbalance or dip into the soil. Or for example, like even the dams, they have very wide base. What is the reason? All of these things prove that pressure is inversely proportional to the area. So if we need some of the things like where stability is maintained, or like for example of the foundation of the house or the dam base, all of these are made wide. The reason is that it exerts less pressure on the ground. And when we are talking about the dam, there is another one factor as well, that is the liquid pressure also. I'm not talking about that one now. So all these cutting edges, they have these sharp edges. This one I finished. Next one, we did another, blowing a paper from here. What is the reason behind this? We kept a paper over here. It couldn't go inside. What could be the reason? It's very simple in fact. Guess, what is inside the bottle? Is there anything? Water? No? What is inside that? Yeah, it's air. Air is inside. So when we are trying to blow it, we can't. The reason is that this bottle already has the air. So when I'm blowing here, there is nothing to replace the air or to go displace it, something air like that. So when I blow it, the same place, it's completely packed with the air. When I blow it, my blowing force can't move the paper inside the bottle. The reason is that the space is already occupied. Very simple. That means these objects contain the air, and simply mention to that one. About the squeezing, what could be the reason? What could be the reason? Now we'll talk about the atmospheric pressure. So I'm going to open it now. Okay. When I get hot water inside, what do you think happened? Hot water inside means the air inside the bottle is warmed. So warm air, of course, has, so it of course occupies some less space. Okay. So when it is covered in this way, now it is allowed to cool down. When the air is allowed to cool it, again it contracts. It contracts. When it was heated, the air inside expanded, so it occupied more space. But when it is allowed to cool, then again the air contracted, so it occupied less space. So in that case, less space means there is some vacuum created. And since it is covered, no air can squeeze inside. As a result, what happened is that this whole air around the earth, which we mention as the atmosphere, that atmosphere pressed it. That's why it got squeezed. Next experiment we did on this one. Water filled, and we kept a cardboard and we inverted it. This cardboard did not fall down. What could be the reason? What could be the reason? This is also related with the atmospheric pressure. Again, here the atmosphere around it is pressing. The atmosphere exerts pressure in all the directions, not top, bottom, right, left, nothing. All the directions. That means even in this direction also the atmosphere is exerting the pressure. As a result, this water could not fall down. That was the experiment we did. It is also because of the atmospheric pressure. Another experiments we did few, like when the air was inside it, I could squeeze it, but not too much. Air can be compressed. So according to my the intensity of the amount of the force that I applied on this bottle depends whether I could squeeze the bottle or not when it was covered and the air was inside. But later on, I filled this with water. I could not squeeze it. Very simple. Liquids can't be compressed. That is the simple reason, and that is the reason why liquids are used in all other machines. Now I try to show the Pascal's law. Now you may be wondering what is Pascal's law. It's very simple. Pascal, I showed you the person. Pascal accidentally there is no any recorded version. I mean recorded written things of the experiment that Pascal did. What I mean to mention is that the barrel was there and 10 meters long tube, and when water is poured through the tube, the barrel exploded. What could be the reason? What is the reason behind that? So the reason behind that is because of the liquid pressure. And liquid pressure depends upon height of the liquid, density of the liquid, and action due to gravity. So if I could erase it now, I will write the liquid pressure formula here. So liquid pressure equals to height, density of the liquid, and acceleration due to gravity, HdG. So I will show you that figure again. Can we go back to the laptop and show the figure? So this experiment, when Blaise Pascal, so said that Blaise Pascal performed it, when it is about 10 meters long, it means the height of the liquid is 10 meters. So does not depend upon the mass or does not depend upon the volume of the liquid. Please remember, liquid pressure depends upon the height of the liquid, density of the liquid, and acceleration due to gravity of the earth. So here, acceleration due to gravity, we are staying on the earth, so everywhere around the earth, this value of g or acceleration due to gravity would be the same. Density of the liquid means we are using the water. It doesn't differ a lot, but the only one variation that we could see is the height. So in that experiment, the height of the liquid is 10 meters. And because of that, it exerted the enormous amount of the pressure. Now, if you want to know how much pressure it would create, let's see. Height of the liquid is 10, density of the water is 1000 kg per meter cube, and G is 9.8. So it comes to be 9811 over there, 3 zeros. So this much Pascal. Is it visible there? So I'm just calculating it again. I'll show you this. Can you show it here? So H liquid pressure equals to H dg. Height of the liquid I mentioned as 10 meters. Density of the liquid is 1000 kg per meter cubed, and acceleration due to gravity is 9.8 meter per second square, which comes to be 98 and 3 more zeros Pascal. 98,000 Pascal. And because of that pressure exerted by the liquid, the barrel exploded. And from that experiment, Blaise Pascal is often valued with the name Pascal. The term Pascal is given as the unit name for the pressure. So pressure unit is the Pascal. So SDG. Now from here what we could see is that liquid pressure depends upon the height. If the height is more, then of course the pressure would be higher. And in this bottle experiment, we made two holes. From this bottom one, water came out with a little bit more force. The reason is that this is the height of the liquid, and this has more height, so water can come out with more pressure. At this one, of course, less height. That is the reason. This is what we did. And thank you for this one. We spoke about the liquid pressure as well. We talked about the atmosphere pressure as well. And we were talking about the Blaise Pascal's law. So Pascal's law, what I was trying to mention is that, suppose if this is the bottle and if it is covered with it, if it is contained with water or any liquid inside it, let's close it. And if we apply any pressure at any point over here, the pressure will be exerted in all the directions unequally. Suppose if you are applying 10 Pascal over here and you made a big hole or a small hole anywhere at any point, then the similar amount of pressure would be exerted. Now remember, at this point, this Pascal's law is used widely in the hydraulic machines. We'll be talking more about the hydraulic machines next time. If you want to know more about those hydraulic machines or the Pascal's law, you can often browse the internet. As I'm often iterating that here I will not be talking about the contents. I'm not here to explain, or go line by line with the Pascal's law or go line by line with those content of the book. I'm simply trying to ignite you with the concept. I'm just trying to arouse some curiosity in you so that you become yourself a problem solver. Let's create the problem like this by yourself. And I often mention, if you have a quality question, then you can have a quality answer. A very significant question will of course create something good answers. That's what we have been talking from the first episode till now. So this is what I would like to mention. I'll be back in 1 minute. Then till now, just give me a break for 1 minute. Now, completing this few experience, I'm showing you some of the sites that would be very useful for us. The first one, can you connect with the laptop, sir? For the contents, for the knowledge section, I have given you one site, khullakitab.com. I'll just show you what to do. There are lots of information given in it, so I hope you would go over here. Khullakitab.com, isn't it? KHULLAKITAB.com. Google. It's not connected? What? Okay, I got this one now. Now clicking over here,
यहाँ तो slide आइरहेछ
I changed. Is it not showing?
No, I'm getting that.
You got the slide on it,
Yeah,
but I've changed the view.
I'm just getting slides. Yeah, now we got it.
Okay, so this is what khullakitab.com. I did it. You can just Google Khulla Kitab, KHULLAKITAB. Now here you can have the books, class 8, class 9, class 10. Suppose I'm going to click class 10. Oh, sorry. Yeah, class 10. Then science. Science, we have got the chapters list here. So I'm talking about the pressure. Let's click the pressure. Okay, these are the notes that we need to memorize. So pressure is force per unit area. We have got pressure equals to F by A. Then we can define what is 1 Pascal, liquid pressure, and also liquid pressure depends on what things. So Pascal's law. So all of those things we discussed today, and of course atmospheric pressure. Maybe it's next slide. So this is what I'm trying to show you, that it is the very useful information. Like very informative side. You can go on this side for the notes. This is what I mean to say. And one more thing, the first question that we discussed today, if you remember, what would happen if Earth had 2 moons? And this one also I would like to show you from the YouTube. So I would say, what would happen if Earth had 2 moons? Okay, I got this now. What if Earth had 2 moons? There are lots of things. So click on any one and go through it. So click on any one. Is it audible? No? Okay, anyway, it's not audible, seems not audible. But what I mean to mention is that this is the way that you can search from the internet. Okay, anyway. What would happen if Earth had 2 moons? Now, this is the question I have raised. So I spoke in terms of gravitational force only. So more you can go on by yourself. So with this, let's conclude our class today. The most important thing is not with the content that you have in the books. We are not here just to tell you about the content. Please be very clear that we really want you to be conceptually clear. We really want you to be imaginative. We want you to be a problem solver. We want you to be a decision maker. We really want you to be a explorer. And of course, be friendly with the technology as well. As I mentioned that Nepal government has also mentioned the technological skills as one of the important skills. It's not like that in those last 200 years, people used to learn the way that we can copy it now or we could follow it now. It's completely different now. It's totally different. I often mention you that let's become a self-guided learner. Let's become a self-guided learner. If I have a curiosity in my mind, then I have got the laptop or I have got the mobile, just click the questions into Google or the YouTube and find more. It's not that I'm going to feed you with a fish. I'm just trying to give you the fishing skill. So once you have the fishing skills, wherever you go, you can catch the fish. With this note, we'll be finishing for today's program. And once again, thank you everyone for watching this one. We'll come again tomorrow at 4 p.m. with more episodes. Thank you everyone for watching us. Thank you very much.